So welcome again. Today we're going to be treating a question on chemistry and it's going to be a past question in preparation for NECO. Now before we start, I just want to say a few things. Don't just see the video and think maybe you are not a student or you are not a science student, hence it's not going to be beneficial to you. When you share, and of course, others who are science students and who are taking NECO will also benefit from it. And of course, when you subscribe, you always get notification when we post new ones. So we have a question that says the atomic number of iron is 26. The number of unpaired electrons in the ion 3 ion is dash. Now there are a few hints I've dropped on the board to help us understand and solve this question very easily. The first of all is that we have four orbitals. The s orbital will be presented with a single box and it takes a maximum of two electrons. The orbital that has the three boxes and a maximum of six. The d orbital that takes five and a maximum of 10 electrons. And of course, the f orbital that has seven compartments and takes a maximum of 11. Now, how do we fill the electrons in the orbitals? You have to first of all stretch out the electronic level. So for iron, first of all, as an atom, we stretch out the electronic level. Now, if as a beginner, how do I get the electronic level? So we start with 1s, 2s, 2p, 3s. We arrange it like this. Now, there's a rule called Aufbau's rule that helps us to determine which of the energy level comes first. It says draw diagonal lines to end in each of the lowest orbitals, starting with the s. So the first diagonal line ends with 1s, so we are going to have 1s here. And of course, because the s takes a maximum of 2, we are out with 2 electrons. Another diagonal line ends in 2s. Of course, 2x will take another 2 electrons. Now we have another diagonal line ending in 3s, but it starts with 2p. So we have 2p. So 2p taking a maximum of 6 electrons. Then the 3x now taking a maximum of 2 electrons. Then we have another diagonal that ends in 4x. Of course, it starts with 3p taking a maximum of 6 electrons. And our 4s taking a maximum of 2 electrons. Now, if you look at this, we already have 20 electrons. Now we are left with 6. Now the last one comes here that ends in 5s, but it begins with 3d. So the 3d, and of course d can take up to 10 electrons. So that means it takes all the 6 electrons. Now, at this stage, we have the electronic configuration of iron. Now, but how about this is the iron as an atom, but we are talking about iron as an ion, as a charge. So, what do we know about ion 3? Ion 3 means iron has lost 3 electrons. Now, where does it lose the electron from? As a rule, even though 3d, now even though 3d is the highest energy electron here, electrons go away first from the outermost shell. So which means two of these electrons will leave from the 4s. So instead of having 4s2, we are going to have our 1s2, 2s2, 2p6, 3s2, 3p6, 4s0. It has lost 2 electrons. Then the third of the electron will go away from 3d. So now we have 3d5. Please take notes. 4s being the outermost shell loses electron first before 3d, even though 3d has a higher energy level. So now 3d has 5 electrons. So how do we now tell the number of unpaired electrons? We can now stretch out our d orbital. So this is our 3d orbital. You can leave out the rest that has 5 compartments. 1, 2. So this is our 3d orbital. We can just focus on the outermost orbital and leave out the rest because they are all complete. Now we are going to now put all 5 electrons in this d orbital as it shows here. And there's a rule that guides how we do it, called Hund's rule. Now Hund's rule says if you are filling orbitals like your p, d and f that have compartments, we call them degenerate orbital, you fill each compartment 1, 1, 1 singly before you pair if they are excess electrons. So let's fill all 5 electrons. 1, 2, 3, 4, and 5. So at a glance now we can see that how many unpaired electrons are there? There are 5 unpaired electrons. So based on what we've done so far, we've been able to see that there are 4 orbitals. The s orbital, the p orbital, the d and the f orbitals. We've seen each of them. S can take a maximum of 2, p can take a maximum of 6, d can take a maximum of 10, f can take a maximum of 14. We've also seen how a Abba's rule can help you generate the order of the energy levels even without cramming it, especially in the exam condition. And we've seen how Hunt's rule helps you to put the electrons when you have degenerate orbitals, pair them, put them singly first before pairing. So that's how we do it. Look out for the next question. Watch, like, subscribe so that each time we put more videos, you get them, and share so that others can benefit from it. Thank you.